Okay, students, good morning, all of you. Today we can discuss some of the revision problems and we can see how to convert kilometer per hour into meter per second and meter per second into kilometer per hour. See, students, conversion of kilometer per hour, conversion of kilometer per hour into meters per second. So this is the task I want to do it. So see, students, kilometer per hour into meters per second. So kilometer by hour. So 1 kilometer by 1 hour is equal to how many? So meters per second. I want to check this, students. Okay, students, 1 kilometer symbol, you know, 1 kilometer symbol is equal to 1 km. So 1 kilometer symbol is equal to 1 km and 1 hour symbol. So 1 hour means 60 minutes. 60 minutes. Okay, students, see, 1 hour simply we write it as 1 HR. So 1 kilometer. So 1 kilometer means we just write here 1000 meters. 1 kilometer is 1000 meters, we know, and 1 hour means 60 minutes. Then 1000 meters by 60 minutes, write it 60 into 1 minute, again write it 60 seconds. So then what will you can see, students? 1000 meters by 60 into 60 second. Okay, students. So then we can write like this: 1000 meters by 6 into 6, 36, and we have 2 zeros here, 2 zeros, and second is left. Okay, students, then 2 zeros gets cancelled. What will you get here? 10 by 36 is left. 10 by 36. So 10 meters upon second. Okay, students, then cut it with 2. 2 5s are 2 18s are. Then what will you get, students? 5 meters by 18 seconds. So that is called 1 kilometer per hour. So 1 kilometer by 1 hour. So 1 kilometer by 1 hour is equal to, so 5 by 18 meters per second. So like this you can convert the units. Okay, and the next one is, for example, I have given 72 kilometer per hour. 72 kilometer per hour into, so into meters per second I asked. How many meters per second? Okay students, then so you write it 72 kilometer per hour, write it 72 kilometer per hour, 72 into 1 kilometer per hour, you write it 1 kilometer per hour. Okay, then 72 into 1 kilometer per hour is, so 1 kmph, 1 kilometer per hour is 5 by 18 meters per second. So right here 5 by 18 meters per second. Then 18 fours are, then 4 into 5, then 4 into 5 you will get 20, so meters per second. So 72 kilometer per hour into meter per second, so we are getting, so 20 meters per second. Similarly, convert 90 kmph, 90 kmph into 90 kmph into meters per second, into meter per second. Then 90 into 1 kmph. So 1 kmph is 5 by 18 meters per second. So write it 5 by 18. Then 18 5s are 5 into 5, 25. Then 25 meters per second. Like this, we can convert kilometer per hour into meters per second. Okay, students. Okay, students, convert 30 meters per second into kilometer per hour. 30 meters per second into kilometer per hour. Okay, students. So now what we are doing, you see, 30 meter per second is how many kilometer per hour? That is a question mark. Okay, so we know that. So we know that 1 kilometer per hour. So 1 kilometer per hour is equal to, so what you write, 5 by 18 meters per second. So okay students, but we should convert, see, 1 kilometer per hour. So what is the relation we have? 1 kilometer by 1 hour is equal to 5 by 18. So what do we have? Meters per second. Now do the cross multiplication. So 18 into 1 km, you will get 18 kilometers. So by 1 hour, 5 into 1 hour, you have 5 hours. That is equal to meters per second. So I just do cross multiplication. I left here only 1 meter by 1 second. Okay students. So 1 meters per second is equal to, so what do we got it? See, 1 meter by 1 second. 1 meter by 1 second is equal to 18 by 5 kilometers per hour. You just remember these two relations. So 1 kilometer per hour, just now we got it 5 by 18 meters per second, and 1 meter per second is equal to 5 by 18 kilometer per hour. Now come to the problem. So 30 meters per second. 30 meters per second. 30 meters per second. So this is I am writing 30 into 1 meter by 1 second I am writing. So 30 meters per second means you write it 30 into 1 meters per second. Okay students. Then 30 into 1 meters per second. Since 1 meter per second is equal to 18 by 5. So what will you write? You write 18 by 5. So 1 meter per second is equal to 18 by 5 kilometer per hour. So kilometer by hour. Okay, then 5 6 so 5 6 30 and 18 6 108. So 108 you are getting. So 108. So what will you get? Kilometer per hour you are getting. So this is the 30 meter per second into kilometer per hour we got. So that is 30 meters per second is equal to 108 kilometer per hour. Both are same. Okay, we can see one more model, students. Next, convert. So convert 40 meters per second into kilometer per hour. Do it, students. Convert 40 meters per second into kmph. Okay. So then what will happen? You see 40 meter per second into kilometer per hour. Okay. We know that 1 kilometer by 1 hour is equal to 5 by 18 meters per second. This is a standard relation, remember it. So 1 kilometer per hour is equal to 5 by 18 meters per second. Now we are doing cross multiplication. 18 kilometer by 5 hours. So 18 kilometers by 5 hours is equal to 1 meter by 1 second. Okay, students. So what is the relation we got it? See. So 1 meter by 1 second. 1 meter by 1 second is equal to 18 by 5 kilometer per hour we have. Okay, students. So now 40 meter per second into kilometer per hour we want. So 40 meters per second. So that I will write 40 into 1 meter by 1 second I will write. 1 meter by 1 second. Then 40 into 1 meter by 1 second is 18 by 5. So 18 by 5. What do we have, students? Kilometer per hour. Okay. Then 5 8 are 40 and 18 into 8. 144. So that is 144. So kilometer per hour. So this is the answer. 144 kilometer per hour. That is equal to 40 meters per second. Okay, students. Okay, students, see exercise 1. So 14th problem. Exercise 1, 14th problem. Find the time taken by a bus moving at 60 km per hour to cover a distance of 500 meters. Question is, find the time taken by a bus moving at 60 km/h. So speed is given 60 km per hour. This is the given speed. Find the time taken by a bus moving at 60 km/h to cover a distance of 500 meters. To cover a distance of 500 meters, question mark is time. Find the time taken. So question mark is time. Okay, students. So we know that V is equal to S by T. Then we will get T is equal to, so what will we get? S by V. So we want time. So T is equal to S by V. S is in meters. So distance is in meters and it is in kilometer per hour. So speed is in kilometer per hour. Okay. I want to convert this 500 meters. 500 into 1 meter is 1/1000 of the kilometer. And see students, there is a small hint for you. This is meters and this is kilometers. And if we have a doubt, when you are converting the smaller unit to bigger unit, so this is 1 meter you have. 1 meter means 1/1000 of the kilometer you can write it. So 500 into 1/1000 you write it. 2 zeros gets cancelled. Then you will get 5/10. 5/10, that is 5/10 is left. So 5/10 means it is 1/2 kilometers. Then you can cut it 2 now for 1/2 kilometers. So speed is in kilometer, distance half kilometer. So distance is half kilometer and speed is also in kilometer per hour, kmph. Okay students. Okay. Then we will get time t is equal to, so 1/2 into 60. So 1/2 into 60 hours you will get. Okay students, see exercise 1, problem number 14. So what is given? Find the time taken by a bus moving at 60 km/h. So speed is given 60 km/h. So I want to convert this 60 km/h into meter per second. So 60 into 1 kilometer per hour. Then 60 into 1 kilometer per hour is 5/18 meters per second. That is called V. Then so 6 3s are 18 and 6 10s are, okay. Then 6 3s are 18 and 6 10s are 10 into 5 50. Then 50/3 meters per second. So V is equal to 50 by meters per second we got it. Okay, that is the speed value we got it 60 km/h. And distance they have given S is equal to 500 meters. Okay students, question mark is time. Find the time. Then we will write time t is equal to, so t is equal to S by V. Time is equal to distance by speed. Since V is equal to S by T, we know that speed is equal to distance by time. So then t is equal to s by v. So s value how much? 500 meters. So s value is 500 meters and speed is in kilometer per hour. We converted that into meters per second. So that is how much, children? 50 by 3. So meters per second you have. Okay, then this 0 0 gets cancelled 5 times. 5 times it gets cancelled. 10 and meter also gets cancelled. Or do one thing, students. It is confusion for you. So see students, distance is given 500 meters. Speed we got it how much? Speed is equal to 50 by 3. So 50 by 3 meters per second we got it. 50 by 3 meters per second. Then 500 meters. 500 meters and reciprocal of this. Denominator you have 50 meters and this goes to numerator 3 seconds. Okay, that is the time t. Then this meter gets cancelled, 0 0 gets cancelled, 5 times are 10 into 3, 30 seconds is the time. So this is the answer, students. Okay. Okay students, now next question 15. So what is given? See, find the average speed of the bus. Average speed of the bus. Question mark is average speed. Question mark is average speed. Find the average speed of the bus if it travels a distance of 3.5 kilometers. If it travels a distance of 3.5 kilometers in the time of 5 minutes. In the time of 5 minutes. This is the question mark. Find the average speed. Find the average speed of the bus if it travels a distance of 3.5 kilometers in 5 minutes. Okay students, I will convert this time into hours. Time t is given 5 into time t is given in minutes. 5 into 1 minute. 5 into 1 minute. 5 into 1 minute is 1 by 60th of the hour. Okay students, then the time value will become 5 12s are 1 by 12th of the hour. Time t is equal to 1 by 12th of the hour. So we have the time in hours and distance in kilometers. We want to find average speed. Now V average equal to total distance by total time taken. So total distance we will write it 3.5 kilometers. Total distance is 3.5 kilometers. Total time is 1 by 12th of the hour. Total time is 1 by 12th of the hour. So then V average is equal to 3.5 into reciprocal of this 12. So you will get 3.5 into 12. Okay students. Then multiply 3.5 with 12. So what will I get? You see 3.5 into 12. So 3.5 into 12. 12 5 is 60. 0. 12 3 is 36. 36 plus 6 42. And after one digit we have to put the decimal 42. So means 3.5 into 12 we are getting 42 kilometer per hour. This is called average speed. And if the options are in meter per second, you convert this kilometer per hour into meter per second. So see, we are writing 42 into 1 kmph. So then 42 into 1 kilometer per hour is 5 by 18 meters per second. Then so what do we have, students? 42 into 5 by 18. This is 42, you know, 42. 42 into 5 by 18. Then 6 7 are 42. 6 3 are 18. 7 5 are 35. 35 by 3 meters per second. So the answer is 35 by 3 meters. Okay, students, how to find distance and displacement when the particle moves on a circuit? We are going to discuss now. Okay, students, see, this is a circle and the center of the circle I am taking O. O is the center of the circle, and line joining from center to any point on the circle is called radius. So this is the radius, and again from center to any point on the circle, this is also again radius r. Okay, consider that a particle has gone from P to Q. So it has gone from point P to point Q on this circle. So PQ is called arc length, and this arc length is making an angle theta at the center. Then find the distance and displacement. Okay, is a question mark. Then distance is equal to, in this situation, distance that is equal to PQ. So that is equal to, what is the length of arc? Distance means it is the length of arc. Okay, students. So we know the formula, angle is equal to angle theta. We know the formula, angle is equal to length of the arc, that is called PQ, by radius of the circle, which is called r. Okay, students, then PQ is called distance. So PQ is equal to r into theta, you can follow. This is called distance. So how much length it is traveled, you got it about distance. Now next one is displacement. So this is the initial point, you know, and this is the final point. Irrespective of the path followed, we don't consider the path. What is the path it is followed? So the direct line segment, the line joining from initial point to final point, the line joining from initial point to final point is called displacement. So this straight line is called, what is that, students? Displacement. Okay. So now for this arc length PQ, and this is let x be the displacement. I want to find this displacement. To find the displacement, I am dropping a perpendicular from O to P. to this line. Okay students, now it will become the angle bisector. So you know this is totally theta. This is totally theta, you know, and then this will become theta by 2. This is the theta by 2. So then this is called opposite side x, and this is also opposite side x. This angle also theta by 2, you know. Okay students. So fine. Good morning students. You completely do problems based from exercise 1, 2, 3. So do all the problems related to exercise 1, exercise 2, exercise 3 and 4, and mostly we covered average speed, average velocity, different kinds of speeds and different kinds of velocities we have covered. So do all those numericals. And write all formulas at one place, and do minimum 4 to 5 problems. Every problem should be different from the previous one. Like 4 to 5 problems you do for every formula, and practice well and write the exam. All the best to everyone, and write it happily. So now I'll write some of the formulas for average speed and average velocity. I will write the formulas. Okay, see students. So consider an object is started here. At the A point it is started. At point A it is started and moving to B. So A to B, let the distance is T1, let the distance is D1, time taken is T1, and with the speed V1. This point B, and B to C, it covered a distance D2, time taken is T2. And C students, next one is C to D. C to D, covered distance is D3, time is T3. Next E, like you have D4, D5 distances. Time taken to travel these distances are T4 and T5. These are the time takens. Okay students, to move from A to B, B to C, D, E and F. Okay. And first A to B, it maintained a speed V1, and C to B, speed V2. Here is V3, here is V4, and here is V5, like different speeds, different distances, different time takens. Then we are asking, what is that? Average speed formula. So then we are asking average speed in this journey. So what is the formula you write students? See my dear students, here we have V1. V1 is equal to D1 by T1. V1 is equal to D1 by T1. And V2 is equal to, so what is that? D2 by T2. And V3 is equal to, what can you write? D3 by T3. V1, V2, V3. And the next one is what? Like V5. So like V4, distance traveled D4, time is T4, and next V5 is equal to D5 by T5. Like we have different distances and different times. Okay, students. So then average speed formula we want. Average speed is equal to. So what will you write? Average speed is equal to total distance by total time. So d1 plus d2 plus d3 d4 plus d5 by total time. What is that? T1 plus T2 plus T3 plus T4 plus T5. Okay, students, like different distances and different times we have. If they have given directly d1, d2, d2, all distances are given and all times are given, then you can use the formula directly. So write all distances in kilometers, all times in hours. We will get a formula. Otherwise, for example, they did not give the distances. They have given only velocities. For example, you have only two distances, then V average. If you have only two distances, then V average formula will become d1 plus d2 by, you will get t1 plus t2. So then you will get t1 plus d1 plus d2 by t1 plus t2 you will get. Means if we have two distances and two times. Okay, this is the average speed formula. For example, distances are not given. V1, V2s are given. Only V1, V2s are given. So then this d1 can be written in terms of velocities. No. For an average speed. Now I want to see, students, average speed. Now I want only in terms of velocities. V1 into T1 plus V2 into T2 by, what are you writing? By T1 plus T2 you are writing. This is called average speed formula. So V1 into T1 plus V2 into T2 by T1 plus T2. If you know only speeds and times, so distance you can write, no, d1 is equal to v1 into t1, d2 is equal to v2 into t2. So instead of d1, v1 t1 plus v2 t2 by t1 plus t2 I have written. Okay, students, and suppose the same average speed we have in terms of distances are given. D1, D2s, you have different distances, you know, D1, D2s, two distances you have, but you don't know the times. Times are don't know, but speeds are known. V1, T1 are known. Then T1 makes subject here. If you make T1 subject here, this T1 comes to here and V1 comes to here. Then you will get D1 by V1 plus D2 by V2. This is for if you know two distances and two respective speeds. Two distances and two successive speeds you know, then this is the average speed formula. This is the formula for average speed. And if you know two distances and two times, this is the average speed formula. And if you know two speeds and two times, V1, T1 are known, then this is the average speed formula. Okay, students, means you have like some 5 distances. You can write D1, V1 into D1, D2, V2 into D2, D3, V3 into D3. Like you can keep writing for, if you know for two distances and two times, you can write for 5 distances and you can write for n distances also. Okay, students. Now next one is, okay, students, if times are equal, then how does the formula changes? You see, two equal intervals of time. So equal intervals of time. If you have equal intervals of time, equal intervals of time you have, equal intervals of time we have, then how does the average speed will changes you are seeing. So times I have, speeds I have, equal intervals, times are same. So then T1, T2 are same, this T1, T2 are also same. Okay, V1, T1, V2, T2 by T1 plus T2. So time intervals are equal, T1, T1, this is also same, 2T, and you take T common here. Then how does the formula changes you see students? V average is equal to V1 plus V2. What will you get students here? V1 plus V2 by, so V1 plus V2, and what is the common? T. We have T common, and in the denominator T plus T we have 2T. In the denominator we have 2T, and T gets cancelled. V average is equal to V1 plus V2 by 2. This is the average speed formula when two speeds are there and V1 and V2 speeds are maintained for equal intervals of time. Okay, if distances are same, two equal distances are same, so D1, D1 and D2 are same. So D plus D you have, what's the formula students? 2D you have, and in the denominator also D take it common, then what will be left? 1 by V1 plus 1 by V2, and D you are taking common. Then if you do this, okay, if you follow this, we'll get this formula is, so yes, we will get the formula is, what's the formula we will get, you see students? What is the formula we have? V average. So V average is equal to, so we will get 2 V1 V2 by V1 plus V2 for equal distances. Different speeds are maintaining, but covering distances are same. V1 speed is different, V2 speed is different. But with V1 speed, if it went d kilometers, V2 speed also it covered same distance only. So same distances it is covered, then the speed formula will change like this. Okay students, and I can take the reciprocal of this one. If I take the reciprocal of this, then it will become V1 plus V2 by 2 into V1 V2, that is called 1 by, this is reciprocal, this is also reciprocal, V average, and send this 2 to here. Then 2 by V average equal to V1 plus V2 by V1 V2, V1 plus V2 by V1 V2, and so that is nothing but you can write that is like this also, 1 by V1 plus 1 by V2. Okay students, you keep solving formulas and the same concept, the same formula once after finishing the problem. What you have done, one recap yourself and how it came, what are the assumptions we made, and what are the things we considered. What is equal distances, then how the formula changes. Equal times, how the formula changes. What is the consideration we have taken. On that consideration, what are the answers you got. You check it. So then use that formula wherever it is useful for you. Okay, and next see students, and it is a straight line. These are all distances in a specified direction. In a straight line motion, distance is nothing but displacement. So in straight line motion, distance and displacements are same. So that's why speeds and velocities are same. So all these formulas we can use for speed and we can use for velocity when they are moving in a straight line direction. Okay students, so all the best once again, all the best to everyone. Please concentrate and write the exam well. Thank you all.